Okay, so now I'm going to be taking you through reduction formulae. Very much important that you understand the word reduction. It has to do with reducing some things. Formulae, okay, it has to be a formula that reduces something. What exactly are we reducing? Since we are still on trigonometry, that has to do with the angles, possibly we might be reducing an angle. So a reduction formulae are used to reduce the trigonometric ratio of any angle. Remember, the moment I say trigonometric ratios, just think of cosine and tan. Nay. For now, temporarily forget about the reciprocals. Let's assume reciprocals to be something else. But every time when I say trigonometric ratio, I'm simply talking about the sine, tan, and cos. So reduction formulae are used to just reduce the trigonometric ratio of any angle to the trigonometric ratio of an acute angle. Yeah, it sounds complicated, it sounds difficult to understand mathematically, but let me try to break it down. Since I said trigonometric ratio, I could be talking about sine, cos, or tan. So what I meant was, if you have any of these trigonometric ratios, as long as the angle it's not an acute angle, it means it could be obtuse reflex or a revolution. I hope I'm representing it correctly there. So a reduction formula is used to reduce it to an acute angle. So that means any angle which is not an acute angle, we use a reduction formula to reduce it back to acute angle. So that includes angles, let's say, since here it's 90, then it means all other angles on this side, they can be reduced using reduction formula, so that we reduce it to becoming an angle which is between 0 and 90. So that means even 210, it's a big angle which can be reduced using a reduction formula. So I just wanted to explain mathematically what I mean when I say a reduction formula is used to reduce a bigger angle to an acute angle. That's it in short. You will notice that as we continue. So that should be the starting point in you understanding what exactly a reduction formula is. But most importantly, for you to easily be able to understand and apply those formulae, they will be based on this. If you remember a Cartesian plane, I'm pretty much sure that you remember on the previous lessons that we said this is the cast diagram, just to keep things simple, where we said all the trigonometric ratios in this quadrant are positive. It's only sine which is positive, it's only tan which is positive, it's only cos which is positive in the fourth quadrant. So that's what you need to be aware of. Okay, maybe let's say since here it's 0 degrees and 360 degrees, and then here we have 180 degrees. I want us for now to focus on that line, which is the supplementary for the supplementary angles. Or let's say we focus on the x-axis, and then at a later stage we will look into the y-axis. Those angles operate differently. So it's fine, don't worry that much. I'm just trying not to complicate it or saying too much of big words and all of that. But let's just be honest about something honorable member. Maybe let me change a color there and say, would you agree that all the angles that fall in the second quadrant, remember this is quadrant 1, this is quadrant 2, this is quadrant 3, this is quadrant 4. So all the angles that fall in the second quadrant, those angles are 180 minus. Because when you say 180 degrees and you minus whatever acute angle, whatever angle, it takes you back in the second quadrant. But if you say 180 plus, it takes you to the next quadrant. So that means all the angles that fall in the third quadrant are the 180 plus. For example, 180 plus 2 is 182. It falls in the third quadrant. Then the ones falling under fourth quadrant, it will obviously be 360 degrees minus. So that means 360 degrees minusing an angle, and that will take you in this quadrant. So trust me when I say this topic, it's not that much complicated. It just needs you to pay attention, and you just need to pay maximum attention. You might not understand where all of this is going and all of that, but the nice thing with my lessons is that you will connect the dots at the end of each lesson. So I won't leave you hanging, whereby tomorrow I'll continue from where I left off, and then only after a week that's when you start connecting the dots. Nope. That's how you should study. You start to finish whatever that you've started. Make sure that by the time you leave, at least you've connected the dots, so that when you continue, you will sort of have an idea of where you are going. So I'm pretty much sure that you now understand that I've just made how many reduction formula. Let's say this is reduction formula number 1 and number 2, reduction formula number 3. Yes, I'll just limit it to that at this stage, so that it doesn't confuse that much. So let me give you an example and say you may be given something like, let's say, sine of 180 degrees. Maybe let us minus an angle there, and they say evaluate this thing as an example. So how do you work it out? You don't need too many steps. In just one step you will be done, and this is how you work it out. You always work it out in reverse in terms of interpretation. You will firstly say 180 minus an angle. It falls in which quadrant? It falls in quadrant number 2. Nay. And then in quadrant number 2, this trigonometric ratio, is it positive or negative? It is definitely positive. You can see by the cast diagram, it is positive. Then it means instead of you having 180 minus that, you will just rewrite it as positive, because in that quadrant it's positive, and then it's sine an angle. Then you are done. That's how easy it is. Nothing complicated. Just like that, you are done. I will show you how I used to prove if what I've made is wrong or correct, because what makes it to be correct is for you to have a final answer which is with the correct sign. If you are not careful, you will end up having a negative sign where it is supposed to be positive. So it's easy for you to do it correctly if you follow these steps. Let's maybe do another one. Let's say you are given cos 180 degrees, and then they say minus minus theta. So again, this is how you do it. You will always need this thing of the cast diagram. If you just say a cast diagram, so it's quadrant 1, 2, 3, and 4, where cos is positive in quadrant 4, all of them positive in the first, only sine positive in there, only tan positive in there. That's how you interpret that cast diagram. So what did I say? Interpret it in reverse and say this thing of 180 minus an angle, in which quadrant does that fall? It's in the second quadrant that we know. So it's in quadrant number 2. In quadrant number 2, okay, let me just be careful and say, don't write this thing of that and then you say 2, because it will look like you are dividing that by 2. Because I know you're going to do that and then it looks like you've done something else. So just say 180 minus that, it falls in the second quadrant. So the question is, in the second quadrant, is cos positive or negative? Cos is negative in the second quadrant. Why? Because it's only sine which is positive. Anything else is negative, which means tan and cos are negative in that quadrant. So in this quadrant, it's only tan which is positive. That means sine and cos are negative. In this quadrant, it's only cos which is positive. That means sine and tan are negative. So that is why I'm saying in this second quadrant of 180 minus an angle, that's where only sine is positive. Therefore, you will write it as negative cos. And then you just write that angle. So can you see? We have reduced this big angle into a smaller angle. That's what a reduction formula does. You just reduce it from being a big angle to being a smaller one. You just need to be careful of the sign. That's all that you need to do. Let me be fair and include one that has tan and say tan 180 degrees, and then I'm just going to minus, let's say, that there. Same principle. 180 minus in which quadrant? Second quadrant. Is tan positive or negative? In the second quadrant is negative. That's why you will therefore just write negative tan of an angle. And that is the end of it. Not that much complicated, straightforward. So now, okay, maybe let's look at another one. Maybe let's say, remember, cast diagram. This thing you will always need it under this part of trigonometry. So let's see. Okay, now this time around, let's say you are having sine of 180 degrees that you plus it with an angle. It's given to you like this. So you need to know in which quadrant does this fall. Obviously 180, as long as you plus it, it takes you to the third quadrant. It would be the second if you had to minus that 180, because it's like you're saying 180 minus 30, which is 150, and it's in the second quadrant. But if you say plus, then it's in the third quadrant. Okay, so now you say, since it is in the third quadrant, is sine positive in the third quadrant? No. It's what? It's negative. That's why you will just write negative sine of an angle. Then you are done. Okay, let's look at another one and say, what if you are given cos, let's say 180 degrees, that we plus it by an angle. This one you will say in which quadrant? Quadrant number 3. In quadrant number 3, is this thing positive? Nope, it's negative. That is why you will say negative that thing. Hope that part makes sense. Easy, 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 easy. So now again, let's do tan of 180 degrees. Again, let's plus it by an angle. So here we will say, in which quadrant does that angle fall? Quadrant 3. In quadrant 3, is tan positive? Yes. So that means this one becomes positive tan of an angle. bese o qetele. So can you see, now I've just taken you through those two reduction formulae, the one for 180 plus and the one for 180 minus. I've just explained to you how those two works. Let me explain how this one works. So those two, I'm pretty much sure that you fully understood how they work. So now let's see. This one for the 360, remember you will always need this thing. Maybe for me, I always had to draw it with a pencil so that I can visualize whatever that I'm about to do. So let's say you have, let's say sine of 360 degrees. Maybe let's minus this one with that. So this one, definitely you will say 360 minus, in which quadrant? Definitely quadrant number 4. In quadrant number 4, is this thing positive? Nope, it's not. Then it means you have negative sine of an angle. Then let's maybe move on to the second one. Let's do this one, of course. 360 degrees. Let's minus an angle there. So we will say, in which quadrant? Quadrant 4. Is this thing positive? Yes, we have C in that quadrant 4. Therefore, it becomes positive cos of an angle. Let's do the last one for tan. We will say tan of an angle. And then we are having 360 there, that we minus it by an angle there. And then we will say a tan into 360 degrees minus that. And we will say, in which quadrant? In quadrant number 4. Is this thing positive? Nope. That's why we end up writing that as negative tan of an angle. Okay, here comes that part where I say I used to somehow prove if my answers are correct. So if you punch on your calculator, you say tan into 360, you can choose any angle. I used to choose between those special angles of 30, 45, and 60. So for example, what I'm saying is, if you put angle 30 there, whatever answer that you get, it will be the same as this one where you put that there. So if you say tan, maybe let's do it. If you say tan 360 degrees, you minus, let's say 30, you close, equals to, it gives you negative 0.57 wara wara. That means if you say negative tan 30, it should give you that same answer with the same sign. So the problem that you might do, it's when your left has a positive but your right has a negative of the same value. So that's how you know you made a mistake with the sign. So what I mean is that even if you say cos into 360 minus, if you put 30 there, it should give you the same answer that you get when you say cos 30 there. Even the sign, it has to be the same. Same as this one where you say sine into that and that. When you punch negative sign that, it has to be the same answer. Same with all these others. That's how I used to prove if my reduction formula has been applied correctly. Okay, I hope you did understand what I've explained there. So I'm pretty much sure that at this stage you are able to connect the dots. So you will definitely be tested where you are given some funny stuff, but trust me when I say all that you need is the cast diagram. That's all that you need. Cast diagram. You can go to an extent of reminding yourself to say, when I'm given 360 minus an angle, it falls in this quadrant. If I'm given 180 degrees plus an angle, it falls in this quadrant. But for me, I never struggled with remembering these things, because I just know that if here is 180, then what falls behind is 180 degrees minus an angle. If it's a plus, is the next quadrant. And then even that one for 360, if it's a minus, that quadrant. So easy, easy, easy easy. So what you may expect, for example, the testing level or the exam level or whatever, they will just give it to you and say simplify. Why would they say simplify? It's because it does not have an equation this time around. So they just give you that and they say simplify it. Simplify it, which means rewrite it in its simplest form. Is it even a plus there? Not a plus. I don't know why, but it looks like this thing is not writing nicely. Okay, so how do you do it? Firstly, look at the numerator. It's like you're dealing with it separately. Cos 180 plus which quadrant? Quadrant number 3. Is cos positive? Nope. That's why I will rewrite it as negative cos of that. Then let's go to cos 180 minus. Cos 180 minus which quadrant? Quadrant 2. Is cos positive? Nope. Then it means it's going to be a negative cos of an angle. Then mathematically we know that negative cancels, cos angle cancels, then you have your final answer being equals to 1. This is the type of questioning that you might need to expect in some of your exams. So let's perhaps look at another one. Maybe let's say this time around you are given, let's say tan, then you have 180 degrees there. Maybe let's plus it with an angle and then we close it. Maybe let's add another one there. So can you see? Okay, so we just add just quickly attend to this. So we just add here. I can just say 360 degrees where I minus that, and then I will divide it, and let's see, we will say tan of 360 degrees, and this time around let's minus an angle there. Okay. So this is it, honorable member. So you do it part by part, not that much complicated. So you see this one, it's 180 degrees plus an angle. Which quadrant? Quadrant number 3. Quadrant number 3, tan is positive. Then this one, quadrant number 4, sine negative. This one, quadrant number 4, tan negative. So it becomes easier to know what to write. So definitely this one, it will be positive tan angle. Then you will be multiplying it by, if it is negative, always put it inside the brackets so that it doesn't confuse you to be a minus. Put it inside the brackets as a negative angle. Then even this one, put it inside the bracket as negative tan of an angle. Then it looks like we are getting somewhere, because that cancels with that sine cancels with that, then you just remain with sine of an angle, and that is the end of it. The nice thing again about simplification is that if you decide to put 60 there, 60 there, 60 there, and again you put 60 there, you get the same answer when you press equal sign there and also equal sign there. That is the nice thing about simplification. So that angle, it has to be the same throughout. If you use 45, it has to be 45 everywhere else you see theta. And then even the final answer, you do the same, and that's how you test if your final answer is wrong or correct. It has to be the exact same answer with the exact same sign. Not that much complicated. If you pay maximum attention and you make sure not to miss, that's why it's important to never miss a class, because once you do or you skip a class, you will not understand what's going on in the class that you missed, or the class that comes after the one that you missed. Okay, so let's say now we add a bit of a spice there and say this is now what we are having. Let's say squared there and say 360 degrees. You know, things get easier as you add more grades. Things are complicated in the lower grades, but as you progress, trust me, things get easier. It's just a matter of checking if you can be able to pay attention. So yes, let's say this is exactly what you are given. So you have 1 minus, let's see, how are we going to do this one? So if you have that squared there, rather do it like this, how I've explained. You see, that squared is actually there, and this thing inside, it is the same as that. So you've got many ways in which you can interpret this thing, because basically squared means 2 of exactly the same thing. So now if squared means 2 of exactly the same thing, so that means this thing is the same as 1 minus a tan of 360 degrees minus that multiplying that same thing. That's what squared means most. So can you see what I'm doing there? I'm trying not to take a shortcut. Someone might show you how to take a shortcut, but trust me, when things are complicated, also being, which means you are going to be in a big problem. Okay, then it's fine. So you still have your 1 minus. This thing is in quadrant number 4. And in quadrant number 4, tan is what? It's negative. So that is why you will need to put it inside the brackets and say, if you have to reduce this thing, this is how it will look like. And this one is forced to be the same, because if you remember, we just said squared means 2 of exactly the same thing. I hope you are following, because remember, this is connected to all that we did previously. Very much important that you pay maximum attention to understand that when you have a squared, it simply means 2 of the same thing. So now what are you having? That negative multiplies with that, it becomes positive. You have tan multiplying with that tan, then it means you are back to tan squared of an angle. I'm not sure what happened there. An angle. Okay, so now you are done. The last part of it is for you to remove the brackets. You have invisible 1 there. It's like you have 1 minus tan squared of an angle. That should be the end of it. If you decide to put 30 there, 60 there, or 45, and you also put it there, you should get the same answer with the same sign. And that's how you know that you have worked it out nicely and correctly. Please try to redo or watch this again before you can attempt any exercises, because it will be based on this information. So I think I'll leave it here and say until we meet again.